Hello friends, I just want to use this video to answer some questions. I shared a video on my TikTok account and some of my followers were asking some questions. In that video, I talk about how to use the Japanese method of multiplication. And I was using two-digit number multiplying by another two-digit number. I also use two-digit number multiplied by a single-digit number. I use a single-digit number multiplied by another single-digit number. But some people were asking, what if you have three-digit number multiplied by another three-digit number or any other number? So I'm here to address that particular issue by using the example on the board. And the example that I have is three-digit number multiplied by another three-digit number. So let me use that one to illustrate that problem. Now, 243 times 132. We have to use the Japanese method to multiply these numbers. So what you have to do is that just follow me what I'm going to do. So if you get 4 digits and you have to multiply by 4 digits, or you have 4 digits and you have to multiply by 5 digits, your duty is just to follow the procedure or the pattern. So what I'll do is that I will first of all take 243. And 243, each of these digits, I will represent them by vertical lines. So what I'll do is that I'll take the first digit, which is 2. Then I will draw 2 vertical lines. Then after that, I will leave space and take the next digit, which is 4, and then draw 4 vertical lines. Then after this, I'll take the last digit, which is 3. So I'll leave space and draw 3 vertical lines. Now, I will now go to the next number, which is 132. So that one, I'll pick the first digit, which is 1, and draw 1 horizontal line on top because it is 1 there. Then, the next digit is 3. So I'll come to the middle and draw 3 lines. 3 horizontal lines. Then I'll move to the next digit, which is 2. Then I'll come down and draw 2 lines, horizontal lines. Then, after this, let me press it. Then after this, where these lines are meeting, you put dots there. So I'll come here, put dot, move to this place, another dot, where they are meeting. Here to the same. Here, the same. Dots. Then I finished putting the dots in this particular diagram. So now, let's now watch how you get your answer from this particular diagram. That is 243 times 132. Follow this. If you don't follow what I'm doing and you have to do differently, you won't get it. You won't get it. So what you do is that you come to this particular place, the corner here, or this particular portion. Your first calculation is supposed to be here. So what you do is that you count the number of dots here. So the number of dots will be 1, 2, 3, 4, 5, 6. Then you write your 6 down like this. Then our next value, we will now consider this and this. We are working it this way, meaning we are adding all of this together. This dots plus this dots. So what I'll do is that I will now count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So what I'll do is that I will now write 7 and carry 1 to the next stage because we can't write all the 17. So what I'll do is that I'll write the unit digit of 17, which is 7, and carry the tens unit. And the tens unit is 1. Sorry, the tens digit is 1. So now, I'll move to this particular stage, meaning I'm adding this together. So what I'll do is that I'll now start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 plus the one that I'm carrying will be 20. So I can write all the 20. What I'll do is that I'll write 0 and carry 2 to the next stage. And that stage, I finished with this. I'm now going to add this and this together. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus the 2 that I'm carrying will be 12. So I'll write 2 and carry 1 to the next stage. So that stage will be here. So here 1, 2 plus the 1 that I'm carrying, it will now be 3. So meaning 243 times 132 is 32,076. So those who were asking, if you have these digits and you have to multiply by another digit, your duty is to follow the pattern. Even if the digits are 7 digits multiplied by 6 digit number, you do it. But because the digits are going to be many, the working will take time. The working will take time. It will be difficult or cumbersome for you to deal with that. That's why in mathematics, if you have a problem, there will be so many ways to deal with that. Some of the methods are simple for smaller numbers, others they can work easily, even though the formula can still work or the method can still be worked there, but it will be difficult for you to do that. For example, if you take binomial expansion as an example, it's a topic in mathematics. Under that particular topic, we have a particular method that we normally use to expand when the power is small for that particular expression, and that is Pascal triangle. And Pascal triangle was discovered by one French mathematician known as Blaise Pascal. He developed that particular triangle, and the triangle involved numbers. So we normally use that particular pattern to solve binomial expressions which are having powers. So that method is simple. It is simple when the power is a smaller power or smaller number. But if the power is too large or it is fraction or negative number, Pascal triangle cannot work. So what you do is that you use binomial theorem formula, which was also discovered by an English mathematician called Sir Isaac Newton. So Sir Isaac Newton is used to work binomial expression with higher powers or when the powers are fraction or negatives. But Pascal triangle is limited to smaller numbers or smaller powers. So if you are to use Pascal method for higher power, even though you get it, but you will suffer. At times you can even use 3 days and you will not finish the question. It doesn't mean that that method cannot use. It can be used, just that it will be too tedious. That's why we have binomial theory for higher powers, fractions, and negative powers. And Pascal is used for smaller powers. So this one too, you can still use the same method to do it and you get the answer. But when the digits are large, there will be another method that you can use to solve it very easily. I was just using this method for you to know that there is a method like this that used to solve multiplication problem, because some people have never seen this particular method. So that is why I was just using it. But when we go further, you see that I will be using different techniques or methods to multiply or add or subtract or divide bigger numbers within some seconds. So I believe that particular question has been answered. So when you take a bigger or larger digits, you just follow this particular pattern and arrange your answer like what I was just doing here. Another issue is, or the question that somebody asked was, if the digits or the numbers that you are multiplying, if they are negatives, what are you going to do? If they are negatives, please just forget about the negative sign. Assuming one of them is negative, just forget about the negative sign. Draw the table and finish. After what you are getting, we put the negative attached to that one. But if all of them have negative, assuming this one is negative, this one is negative, forget about the negatives. When you finish, you write the answer as positive. Maybe somebody will ask why. We have a concept in mathematics. When you are multiplying two numbers and one is negative and the other one is positive, the result is negative. And when you are multiplying two numbers and all of them are negative, your result is positive. It's a concept in mathematics. I'll get time and teach you the reason why negative times positive is negative and negative times negative is positive. I will get time and deal with that particular concept, because I don't want the video to be long, so I will not waste time to explain that particular concept. So I believe that one too is answered. Another question that somebody asks is that this particular method cannot solve for all numbers. It can solve for all numbers. But in the first video, I made some exceptions. I said this method, it can be used to solve whole numbers, but when they are fractions, it cannot be used. For example, 1 over 2 times 3 over 4. I'm just putting a fraction for you to see. So you see that fractions, it will be difficult for you to use this particular procedure. But when the numbers are whole numbers, it can still work. It's just that if the numbers are, the digits are many, that one you use my time to do that. I think I've been able to answer 3 questions. When I went through all the comments, these were the things that I just picked to explain. If I go through the comments and there's another question, then I'll deal with that. Or if you are taking a whole number times another whole number and you are not getting it, you send that particular number to me. I will get time and address it. Maybe you will not understand the whole thing. So when you send it to me, I will be able to do that. I think I've answered 3 questions for now based on the earlier video. Thank you for watching this video. If this is your first time of watching, kindly subscribe to my YouTube channel so that anytime I've uploaded a new video, you'll be able to view it first. Also, share my Facebook post for others to watch. Thank you once again and have a nice day. Bye-bye.